Welcome back, section 6.1, part 2. We're going to start by finding z-scores from known areas or probabilities. So in this case, we're going to use a different function. Instead of norm.dist, we're going to do norm.inv. And so what that looks like is you can, of course, find it by doing the insert, the function, or you can just type it in and always have that equal sign. We're going to put the probability that we know and then 0, 1. So let's look at an example here. We're still talking about the bone density, and they want us to do a bone density corresponding to the 95th percentile. So we're using previously learned language. So we're always going to draw our picture. And so we know that 0 is here, but we have 95th percentile. I am assuming it's going to be like this. That means that the 95% is below. This is 0.95 below. And this is 0.05. I know the area, but what I don't know is this z-score, right? What value, what reading is that? What score separates it? So what we'll do is we'll use Excel. So we'll type it in, inverted or INV, and the probability, remember, we're always looking to the left of the z-score, so that's 0.95. Our mean for standard is 0 and 1, enter, and we get 1.64. And we could say 1.645 if you wanted. So our z-score is going to be equal to 1.645, and that would be the answer. Go ahead and give this one a try. And there's the solution. So with this example here, we have the same standard normal deviation, same standard normal distribution, and now they want to know the test score that separates the bottom 2.5%, so we need to change that to a decimal, 0.025, and find the score that separates the top 0.025. Now, some of you may remember that it is symmetrical, but we're going to pretend like we don't know that, and we'll get more into that later. Now, we know that this information only gives us, the Excel only gives us to the left of the z-score. So we're only going to be able to determine this one right away, because it's already to the left. But to find this one, we could actually we need to figure out, well, what's to the left of this guy? How much is to the left? Well, all of this is just going to be, remember, the total area is 1. Take away this little this little right tail here. So we'll take that away, and that can be the probability associated with this z-score. So we'll go into Excel. And our first one here, we're going to type it in. And our first one, we want the probability. We know to the left is that much, and our mean in there. So that's the answer. But now the other one, we can type it in as well. And we know that the probability, we can just type it right in. We don't need to calculate that if we don't want to, because it'll calculate it for us. And it's going to give us that. So coming back in here, we know that this score is negative 1.96, and this one is positive 1.96. They're symmetrical, and we'll get more into that later. But each of these z-scores is negative 1.96 and 1.96. Go ahead and give this one a try. And there you go. Critical values are going to become super important as we continue moving through the course. And basically, a critical value is a z-score on the borderline separating significantly low or significantly high. And we use this notation here. And it kind of looks like that. When we find the critical value, it's giving the area to the right. To the right. Well, wait a minute. Everything we use goes to the left. So it's super, super important that when we're actually given these areas, that we're really determining 1 minus the area, like we just did in the previous example. Because, again, these are giving us the areas to the right. That is the area. And our technology gives us the area to the left. So that's the probability that we actually know. So again, when we do this, this value is to the right, and we really need the probability to the left. So we'll do 2 more examples together. So find the critical value here. So I like to draw a picture to make sense of it. And remember that the critical value actually gives me the value to the right. So this is 0.025. That's the area to the right. So if I want to use Excel, I really need to type in the probability of 1 minus that value. And again, I'm looking for the z-score. I have the probability. So I'm going to use 1 minus 0.025. Oop, look, I made a mistake. I said, don't use that. There we go. Now we're talking about probabilities. All right, and we find that the z-score is 1.96. And we actually did this problem earlier where we saw that value. All right, let's do one more. So now we've got this critical value here, and it gives me the data to the right. So this is 0.15. So this is going to be 0.1 minus 1.5, and that's how I'm going to be able to get the information from Excel. So I just type it in, and I'm going to hopefully do it right this time. There we go. And that z-score is 1.037. Actually, there we go, 0.036. We're not rounding up with that 4. Or 1.04 works as well. Give these a try. And that concludes section 6.1, part 2.